Let's continue now with more examples of Coulomb's law. So let's suppose that we have an example like a more complicated one on this part of the video series. For Coulomb's law now, we will find the uh, charges and we will find the uh, distance between those two charges when we know the force. So let's suppose that we have a case where the two charges are equal to each other and we don't know what charges are them. But then what do we know? That the electrostatic force that those two charges are experiencing is something like 8.70 times 10 to the power of 5 newtons, and they are apart from each other at a distance of 0.72 meters. So what is the charge and the force that they are experiencing is an attraction force. The fact that we have the attraction force here, that means that what we are dealing with, the charges are not only equal in magnitude, but they have the same nature. So they are both positive or they are both negative. However, we cannot make the distinguish if they are positive or negative, but we can draw the conclusion that those two charges are the same, have the same nature, either both positive or both negative. So now the electrostatic force based on the Coulomb's law is KQ1 Q2 over R squared. Since the two charges are equal to each other, then will be Q, I will say Q, you can say Q1 to the power of 2 or Q2 to the power of 2 is the same thing because Q1 and Q1 times Q1 to the power of 2 over R squared. So you can find the formula from here that Q1, which is equal to Q2, will be the square root of force times distance squared over K. Or if you can put the distance away from the square root, then will be the same thing. So Q1 equals to Q2 equals to the charge Q. It will be in our case as 8.70 times 10 to the power of 5 times 0.72 squared over 8.99 times 10 to the power of 9. And entering this in your calculator, you will find that the charges are equal to 5.02 times 10 to the power of negative 5 coulombs. Okay. And if we have a question in which we are finding what is the radius, then we will use this kind of the same formula. So electrostatic force is KQ1 Q2 over R squared, and then from here R will be the square root of KQ1 Q2 over electrostatic force, so that those two charges are experienced. Okay, now let's see a case when we have more than two charges that are either in a straight line or not. So let's suppose that we have a situation that three charges, charge 1, charge 2, and charge 3 are both in the same line, and then the charge 1 is positive 5 coulombs, charge 2 is a negative 8 coulombs, and charge 3 is positive 7 coulombs. They are apart from each other. The distance between 1 and 2 is 0.3 meters, and distance between 2 and 3 as 0.4 meters. what we are doing here is we are finding the electrostatic force of that 2, electrostatic force net at 2. The principle that we will use on this case is known as the superposition principle. So superposition principle is saying that you will take all the forces that the object is experiencing as one by one, as the rest of them do not exist. So when we draw the free body diagram of object 2, why object 2? Because this is the object of our interest. We are saying what is the electrostatic force net at object 2. So we will see the electrostatic force that 2 is experiencing as a result of 1, since they are opposite charges, will be attraction. So this is the electrostatic force that 1 is exerting on 2. And then when this, supposing that the charge 3 doesn't exist. So this is superposition. And then the electrostatic force that 3 is exerting on object 2, supposing that 1 do not exist, the superposition principle, is again the attraction. And this is the electrostatic force of 3. Now, I would suggest you to draw the free body diagram in this pretty much similar way that I'm drawing here, and then write Coulomb's law below each of them, and then find the magnitude of each of them. So this will be the same as saying K Q1 Q2 over the distance between 1 and 2 squared, and this will be the same as saying K Q2 Q3 over the distance between 2 and 3 squared. So if you enter the magnitude or the magnitude of Q1, Q2, and R1, 2 for the first force here, and Q2, Q3 for the second force here, you will find respectively 3.996 times 10 to the power of 12 newtons and 3.147 times 10 to the power of 3 newtons. So now what we are looking for is the electrostatic force net. And like every net, the electrostatic force net at 2 is the vectorial sum of all the forces that the object is experiencing. So will be FE1 and FE2. And since this is in a 1D direction, so in one dimensional, they are collinear of each other, then we assign 1 as the negative. So negative 3.996 times 10 to the power of 12 newtons plus positive 3.147 times 10 to the power of 12 newtons. And then the electrostatic force net at 2 will be negative, whatever the calculator gives you. So 3.99. 8.49 times 10 to the power of 11 newtons. You can say that electrostatic force net at 2 is negative, that is going west, or you can say it is 8.49 times 10 to the power of 11 newtons going west, or going or toward charge 1. As homework for you will be to find the electrostatic force net at 1 and the electrostatic force net at 3, sorry. Keep in mind when you are calculating it, the distance between 1 and 3 will be 0.3 plus 0.4 meters. Okay, this is the homework for you. Also, as an addition to the homework, let's suppose that you have this situation that you have charge 1 here and charge 2 here. They are in the same line, and then in the same line you are placing a charge 3, which you don't know. So let's say that charge 1 is positive 7.0 coulombs and charge 2 is positive 10 coulombs, and they are apart from each other at a distance of 0.75 meters. Where should you place a charge 3 at? So that, where should you place a charge 3 at? So what is this one here, x? So that the electrostatic force net at charge 3 is equal to 0. This is another question that I'm asking you to think on doing on your own. Let's suppose that now what we have as for you to practice as charge 1, charge 2, and charge 3 are on the vertices of a right angle triangle in which the sides are respectively 0.70 meters and 0.50 meters. And charge 1 is positive, charge 1 is positive 3.70 coulombs, charge 2 is a negative 4.80 coulombs, and charge 3 is positive 5.80 coulombs. So find the electrostatic force net at 1 as homework, and then find the electrostatic force net at 2, and find the electrostatic force net at 3. We will see something like this in class as well. Another question that you should be able to do is you are dealing with an equilateral triangle. So 1, 2, and 3. They are Q1 positive 5.80 times 10 to the power of negative 6 coulombs. Q2 is positive 6.20 times 10 to the power of negative 6 coulombs. Q3 is positive 8.0 times 10 to the power of negative 6 coulombs. And the distance, so it's an equilateral triangle, so the distance is equal to 0.02 meters. What is the electrostatic force net at each of them? 2. And what is the electrostatic force net at 3? And then think about it, what if the 3 charges are equal as well? What in magnitude, in which direction you will have the electrostatic force net? So first consider that they are all positive, then they are all negative, and then you change other charges and stuff like that. We will deal with those kind of questions in class, but I'm just giving you some food for thoughts. And this concludes the Coulomb's law and pretty much everything that is in terms of the electrostatic force. As I said, we will deal with on details with those type of questions in class, but this will be the video series that we have to that you have to discuss. Yeah, on top of this, there is a topic that, on top of all those videos, there is a topic that is in regards to straightening the line. This will be a separated video from the series of electrostatic force, and I will attach that into the files. Okay, I will see you in class.